So when we're solving problems using linear systems, there's really four things that you want to do that are going to help you find the answer. Now, there's a bunch of ways that we could do this. Just a lot of us can look at some questions and just see an answer, or we can just jot down some numbers and get something. But we really want to have a conclusive way that's right every time and explains our thought process and reasoning so we can get full marks when we're doing this. That's labeling our variables and unknowns, making a formula, solving by either substitution or elimination, and then actually concluding the question. Now there's a few types of questions that we can look at here. We're going to look at the main ones. First, this is just a general type of question. So we have 3 footballs and 1 soccer ball cost an amount of money. 2 footballs and 3 soccer balls cost a different amount of money. We're finding the cost of both of those. So typically, the question itself is actually going to give you your let statements. So we're going to have let, and I'm just going to use x and y. X be the cost of a football, and let y be the cost of a soccer ball. Okay, so we've got a football and a soccer ball. We're looking at the 2 costs. So if we're getting 3 footballs in the first case, 3x plus 1 soccer ball, y equals 155. And then we have 2 footballs and 3 soccer balls. For me, this kind of lets itself to using a substitution equation. I'm going to use multiple different ways to do this. So we've got 155 minus 3x. So that's all from the first equation. Then we get 2x plus 3y equals 220. So here we're going to substitute our values in, and we're going to do some multiplying. So I'm going to we'll call this 1, I guess, and 2. We're going to sub 1 into 2. Now what we're going to have when we sub 1 into 2 here, we're going to get 2x plus 3 times 155 minus 3x equals 220. Now this is the part that I said that you always want to use brackets when you're doing the substitution, because we don't want to ever forget that minus 3x is actually multiplied by the 3 as well, and it's becoming negative. So here we're going to get 2x plus 465 minus 9x equals 220. That's going to be negative 7x. We're going to bring the 465 over to the other side, make it negative. We're going to get 245. And then we're going to divide both sides by our 7. Now, that should be negative 245. And we're going to get 35. So we now have x is 35. Now we can take that and sub that into 1. And that's going to tell us what our y value is. 155 minus 3 times 35. We're going to get 155 minus 115. And we're going to get, what is that, 40? Therefore, a football costs, what is a football? $35. And soccer ball costs 40. Okay, so moving on to our next question. So looking at this, we've got Gabriel invests $10,000, excuse me. He invested part at 4% and part at 5%. Now what we need to recognize is as soon as we see a percentage, we need to change that into a decimal. So to change that into a decimal, we divide it by 100, we get 0.04. Now with this question, what we're actually looking at is the values are going to be how much did we invest at each number. Okay, we're going to have a total interest equation, and we're going to have a total money equation invested. So our let statements would be let X be the amount invested at 4%. Whoops. And let Y be the amount invested at 5%. So we know we've invested X plus Y. That's all of the money. That's $10,000. Okay, now again, we could change this around and make this into a different value, or excuse me, we could change it and make it a substitution. We could also look at it this way. We've got 0.04x. We're earning interest on whatever we've invested in at X of 4% plus 0.05. That's all of our Y value, and we've earned $440. Now, if we wanted to, we could then rearrange this or multiply this. If we multiply 0.04 times 25, so what we'll do is we'll times this whole thing by 25. We'll get 0.04 times 25 is going to give us 1. So that's going to be X plus 0.05 times 25 is 1.25 Y. And then 440 times 25 is going to give me 11,000. Now I'm going to just bring my other equation over. Let's make that an actual arrow so that I can line up all of my values. So this is similar now to elimination. We can make this 1 and 2. We can do 1 minus 2. X minus X would give me 0. We're going to get negative 0.25Y equals negative 1,000. Now all we have to do is divide that over. So we have 1,000 divided by 0.25. We get Y is equal to 4,000. Now if we sub that into 1, we can see that, what do we have? X plus 4,000 equals 10,000. And then X is equal to 6,000. Therefore, $6,000 were invested at 4%. And, 4%, and 4,000 at 5%. Okay, that's just using my let statements to read exactly what X and Y mean. I almost made a mistake there and switched them, but X was what we found at 4%, Y at 5%. Moving along, this is similar. What we're doing here is we have a total amount of solution, and we're making a solution out of 2 different types of solution. So in this case, we're actually going to treat it almost the exact same. We have 42% solution that we're creating with 30 and 50. Okay, so how many liters of each? So let X be the 30% solution. Let Y be the 50% solution. We know X plus Y is the total. We're making 10 liters. Okay, so that's the amount that we've added of each of these. So X plus Y equals 10. We know that to be true. Now we know that we're making 30%. Now remember, all of our percentages become decimals. We're using 30% and 50%, 50% to create 42%. But we know how much 42% we're making. We're making 10 of our 42%. Okay, so now we can simplify that. So we have, I'm going to actually rearrange this equation here. We're going to make this, let's make it y equals 10 minus x. We'll call that 1. We can just substitute that straight in. So we would get 0.30x plus 0.5 times y, which was 10 minus x, equals, and this is just going to be 4.2. Just simplify that. So then we get 0.3x plus 0.5 times 10 is 5 minus 0.5x equals 4.2. So now we're going to get negative 0.2x equals negative 0.8. Okay, all we've done is simplified our math there. Now we're going to divide our 0.8 divided by 0.2. And we're going to get x equals 4. And then we can sub that into 1, and we're going to find out that y is equal to 6. And therefore, 4 liters of x was our 30% solution, and 6 liters of our 50% solution. So similar to the last question, we just set it up a little bit different and worked through it. Finally, this last one. And these are all the kind of common ones. So a distance problem, what we're going to work with here is distance and time. Now, however you want to set it up, if you set it up with time, you will have to do a little bit more at the end because the final question is asking how far they've driven at each speed. If you set it up with distance, it's a little more algebra when you're working through it because this is in kilometers per hour, and so is this here. And that just makes our math a little bit harder in the beginning. So what we're looking at here is we're driving at 100 kilometers an hour and 80 kilometers an hour. So we've got let x be, what are we trying to find? Distance. How far did he drive? Be the distance at 100 kilometers per hour. And let's let y be the distance at 80 kilometers per hour. So we know we've gone a total of 500 kilometers. That's an easy one. So we've got x plus y equals 500. Let's solve for x this time. It doesn't actually matter. We know that x is going to be equal to 500 minus y. So that's our first equation. Nice and easy. Our second equation is a little bit harder. Now I said that we're going to do one that was going to be a distance, one's going to be time. Well, we know our total time is 5.5. That's nice and easy. We know we've driven x and y at a certain speed, but what we have to recognize is this is going to be x over 80, because when I divide by that, the kilometers are going to go away and the hours are going to come back up to the top. Or sorry, x is over 100, not 80. X is 100 kilometers an hour, y is 80. Now we need to clear our fractions here. So to clear our fractions, there's a bunch of different ways you could do it. Probably easiest way is to just define a common denominator. So if we were to multiply these both by 400, we would be able to get rid of everything. Or you could multiply it by 800 if you really wanted to. So if we multiplied this by, let's say 800, let's say that's the easiest one. Okay, you're working through and you kind of struggled. All that's going to happen is your math is just going to be a little bit bigger. Okay, so if we multiplied this by 800, we'd get 8x plus 10y equals, and then 5.5 times 800 is going to be a little bit bigger. You're going to get 4,400. So then that's our new equation. And now we can say that that's 2, and all we're going to do is sub 1 into 2. So we're going to have 8 times 500 minus y plus 10y, whoops, equals 4,400. So now we're just going to do our algebra. 8 times 500 is going to give us our 4,000 minus 8y plus 10y equals 4,400. We're going to get 2y equals 400, y equals 200. Now we can sub that into 1. Oh, let's make that 2 words. Into 1, and we get x equals 500 minus 200 is 300, and therefore Quinton drove 300 kilometers at 100 kilometers per hour and 200 at, we'll make that kilometers, 80 kilometers per hour. So all 3 of those were done very similarly. We just set them all up differently. Those are the most common types of questions. So make sure you're careful when you're setting it up, and then just do substitution or elimination.